So, object-oriented programming is a big topic. It's bigger than one chapter. So they actually have a chapter 7, which is more object-oriented programming stuff. But we can get a good foothold on it pretty quickly. I've mentioned that a class, first I'm going to give you a definition, then I'm going to back it up, is a collection of data and the methods that act upon it. That's actually the blueprint for the collection, right? Just like if you have a blueprint, that blueprint is not a house. So, class is a blueprint. A blueprint that describes a collection of data and the functions, methods. I should not use the word functions anymore, we're Java programmers. And the methods that act on that data. Now, does that mean that a class has to have data? No. Does it mean that a class has to have methods? No. But certainly, usually will have both of those. So just for funsies, we're going to open up Visual Studio. We're going to open up NetBeans, and we're going to make kind of a dummy little class that's got static data members, meaning that we don't actually have to instantiate an object of that class. Now, if you remember what I said instantiate meant, it means create a variable of that type. You use the new keyword, like scanner sc equals new scanner. That's instantiating, it's creating a scanner. Sometimes you need to make an object, sometimes you don't. If it's sounds like a Mounds commercial. If it's the math class, you don't have to create a math object. You just use math.py or math.pow. And that's because all of its members are declared as static. So that's what we're going to do. We're going to declare a class where all the members are static. Are your classes normally going to be this way? Well, not in the future, but right now, every class we've had is basically just a main method, right? And it is declared as static, meaning that when Java runs it, it does not have to create an object to hold your class that you've created. It just goes ahead and runs the main method. So I believe today's Lecture M. I'm going to make a new project called Lecture M. Now you should only put one class per file and one file per class. I'm going to remove the package Lecture M statement and then move it to the correct place. So I deleted my package, and then I'm going to come up here and move class to correct folder. Alright, then I'm going to delete extra comments, clean things up a little. Now, you're only supposed to put one class in a file. So what am I going to do? I'm going to put two classes in a file. Why am I going to do that? So that I don't have to switch between pages to see the class. Now, I'm going to try to do one class per file in the future. Just hear the ghost of programmers past yelling at you each time you do this, each time you put multiple classes in one file. But if you do make multiple classes in one file, only one of them can be public. So I'm going to write a class called data, but I'm not going to mark it as public. So nobody else is going to be able to access it. And it's going to have some static members. I don't know what. Well, what do we care about? How about static string, capital S, my name. Static int, my age. And now I'm going to use those variables. Well, I can't just do this. I can't do my name is equal to Bob. Why? Because my name is not part of this method. It's not part of main. It's not even a part of this class. To get a hold of it, I have to prefix it with the name of the class. How do I know I have to prefix it with the name of the class? Because anytime you see the word static, it means you have to prefix it with the name of the class. That's worth writing down. To use a static member, you have to prefix it with the name of the class. To use a non-static member, you have to prefix it with the name of an object. Reference. Like when we do scanner.nextInt. We don't use scanner.nextInt. Scanner's the name of the class. Instead, we create an object like in, and then it becomes in.nextInt. But these are static members. And so, by the way, if it's static, it's also known, static is known as class members, like class variables and class methods. Why? Because you prefix them with the name of the class to get a hold of them. If it's non-static, it's not a class member because you have to have the name of it, of an object. So those are called instance members. Non-static members are instance members. In other words, instance variables and instance methods. Instance is just a fancy name for a reference to an object, right? I make a new scanner, I now have an instance of that object. You have a blueprint, you create a house, that house is an instant of that blueprint. It's an instantiation of it. All right, so I have to prefix it with the name of the class. So data dot my name is equal to Bob. Data dot my age is equal to 13. Now that's all I can store in it. I mean, I could reset those variables, right? I could set my name equal to Alice, you know, my name equals Lady Gaga, you know, whatever I want to put there. But each time I do that, I replace the old value, right? These are just variables that we're overriding. What if we wanted to store 10 pieces of data? Well, we can't, because these are static members, meaning that in the entire project, we have one and only one my name variable, and one and only one my age variable, even if we created an object of type data. Data equals new data, right? We still only have one my name and one my age. That's the deal about static variables. So, we're going to create another class. Oh, and by the way, you C++ guys, the definition's the same except you put a semicolon at the end. Okay, now we're going to make another class, and we're going to give it a similar name, class data2. That's original. Or more data. Same business, but they're not going to be static. String name, because we're not just talking about one name, right? It's not just my name. And then int age. Now these are non-static, so these are instance members. We have to have an instance. We have to create a new object in order to use them. Non-static equals instance variable, instance member, ditto. And I'm going to go up and add a comment here that says static equals class member, ditto. All right, now I can create multiple chunks of data. Down here, I'm going to create some objects of type data, of type more data. Now I'm going to move my braces up a little bit like that. It's going to make it harder to read, but I'm doing that so I get more space on my screen at the same time. Oh, I thought of a way to do that. How about that? All right, anyways, I'm going to put these above the data ones. So this is referencing class members. My name equals static, class member. So let's create an object of type more data. More data, MD1, is is equal to new more data, parentheses in parentheses. And more data MD2 is equal to new more data in parentheses in parentheses. So MD1 dot name, my name, or no, just name, is equal to Sam. MD2 dot name is equal to Sally. And then MD1.age equals 20, MD2.age equals 30, something like that. So let's print that information out so that we can see that Sam is 20 and Sally is 30. So I'm going to use some printf statements. And we have a string and we have a number, an integer, so I'm going to use a %s and a %d. So system.out.printf. %s is %d years old. \n, comma, md1.name, comma, md1.age. And then just copy that line and change the md1s to md2. So in the past, all of our programs have just involved like one set of data, right? You ask for one temperature, you ask for one amount in kilograms, you ask for, one series of test scores, you have one average or whatever. With objects, you can create as many different objects as you want, and each one can contain a different set of data. One of these objects is about the person named Sam. The next one is about the person named Sally, and I could create 20 more if I wanted to. If I wanted to, I could stick them all in an array or a list. I could write a method that would accept that array or list, and average up all their ages or print a report about them all. I guess I should actually run it before I keep bragging about how great it is. All right, so Sam is 20 years old and Sally is 30 years old. So note the syntax. These are non-static members, so we have to prefix them with the name of an object reference, which are known as reference variables. I used to just say you have to prefix them with the name of an object, but the object can have multiple names, really. You could, here, let's create an object that has more than one name. How about MD3 is equal to MD1? Whoops, excuse me. More data MD3 is equal to MD1. And then go and copy one of these print statements, but change the MDs to MD3. So I'm just going to copy that print statement, and I'm going to print out MD3 dot name and MD3.age. And we're going to see the same data that's stored in MD1, right? It's going to print Sam as 20. It's going to print it twice. And we think, oh, okay, we have two copies of the data. No, we have two references to the same data. We only created one object. Now we have two names for that object, but it's like two street signs pointing to the same street. Just because you have two street signs doesn't mean you have two streets, right? You have a street sign on either side of your street. They both, say 32nd Street. So two signs pointing to the same street. Or if it's a long street, right, you can have hundreds of signs for the same street. You can have hundreds of references. That's what they're called, hundreds of references to the same object. So this new keyword created the object and assigned its address behind the scenes. We don't know what that memory address is, right? But it assigned the address into that reference variable. And then here we copy that address into a new variable but they still point to the same thing, right? So if you go and burn down all the houses on that street, it doesn't matter which street sign you use to find out, you know, to hit that street, the houses are still all burned down. So if we change MD3 .h to something, we're going to see that it also affected MD1. So just to prove that, I'm going to make MD3's age equal to 100, right? And if we thought that we had two sets of data, we might expect that the first one is still going to print 20, and the third one's going to print 100. But instead, the first one's also going to print 100 because it's two references to the same object. Right? So Sam is 100 years old. Even though we never changed MD1, all we did is change MD3. It's just that MD1 and MD3 are just two references. Just like if you have multiple shortcuts, right, on your desktop. You know, you like creating aliases or programs or whatever. They're all running the same program. It doesn't matter whether I have a shortcut on my desktop or I've docked one to the, you know, the start menu or down here to the taskbar, right? They're all pointing to the same program. Both of these are pointing to the same object, and so any change to one is reflected in every way we access it. That kind of makes sense? Sort of? Yeah. All right. So in the olden days, a glimpse of stalking. No, in the old days, a standard programming technique was called procedural programming. The emphasis is on the procedures or tasks that make up the program. You design your program around what you think the key procedures are. Now, if you've done a whole bunch of procedural programming, you're free to laugh at this and say that this is wrong. But whatever, you know. The program starts running at the top. It may have some loops. It may have some function calls, but it's not too difficult to follow the path through it. And that's kind of the drawback of object-oriented programming, is that you could create, you know, 20 different classes, and when you're trying to follow the path of execution, well, maybe it jumps over and it starts running this class, and then this class creates this object, and then calls a method, and so it calls that. You know, it can be kind of hard to stitch it all together in your brain, the order in which things are running. And so that people say, oh, object-oriented programming makes things easier. Well, from a certain point of view, but it can be harder to get your brain around than procedural programming, which is, you know, you start at the top, it runs, it calls some functions and modules, and it comes back and it loops, and then it's done, right? It's not creating new objects that are then going to create new objects, and then you have to worry about whether the objects disappear or whatever. I'm making object-oriented programming sound bad, and it's not. It's just an alternate way of looking at the data. So instead of thinking about procedures, we think about the stuff in the program. The stuff is the data, and the functions that act on that data. Those things are called objects. Like if you were going to write a procedural program to calculate the height and the width, or to calculate the area of a triangle, what do you need? Well, you need the base and you need the height. So you go to the top of your program, you declare a base variable and you declare a height variable. You get some input, you do the calculation, you're done. And that's procedural. If it was going to be object-oriented, you would define a triangle class. And each triangle would be able to hold its own base and height. And then if you wanted to, you could create one triangle or you could create a million. Now, the people who've done database programming have the idea that each line in a database, each record of a database kind of works like that, right? You could create a triangle database where, you know, every line in the database, every record in the database is a different triangle, just like if it was a database of people, more likely, huh? So, you know, every row in the database has different, you know, person in it. Their first name, their last name, their address, their birth date, and stuff like that. You could make an object that contains all that stuff. And then when you read from the database, all that stuff could be stored into the object. That's a very common thing, is to have code that ties a database into an object that you create. So an object is a set of related data that identifies the current state of the object and a set of behaviors. That's worded very similar but different to how I said it, right? I call them methods. They're calling these behaviors. Same thing, just different textbooks call them different things. The behaviors are the methods. Behavior is kind of an abstract term. You know, but if you have a triangle class, you might want to assign some methods to it. And the methods might be things like calculate area, and then calculate perimeter, stuff like that. Well, let's make a triangle class and then add a calculate area method to it. So we're going to go and we're going to make yet another class. I'm going to stick this underneath more data. And by the way, does anybody get syntax errors that need me to slow down?
Well, I get something that I...
Oh, I said we were going to do a triangle. So, we're going to make a new class. What's the keyword that starts a class? Class. That's the name of our class. Now, to be a good Java programmer, name all of your classes uppercase letters. That's just the law. It'll work if you don't, but everybody does it that way. You want to be just as cool as they are. So, a triangle has a height and a width. No, it doesn't. It has a base and a height. Int base, int height. But we're also going to add a method that calculates the area. And to my recollection, the area of a triangle is 1/2 times the base times the height. Why don't we make these doubles rather than ints? Double base, double height. Now we're going to make a method. A method is a function that's attached to a class, which is the only kind of function in this language. So it's going to return a double. It's going to be called getArea or calcArea. I like get. And it doesn't need to accept any parameters, so I'm not going to put anything between the parentheses. And inside it, I'm going to just calculate the area. So double area equals 0.5 times base times height. Now I'm going to add something that's going to make it look a little bit more obscure in a minute. And I encourage y'all to do this when you're writing classes, but I'm leaving it off for now. And then return area. So if we were good programmers and we were earning money doing this, we would have created 4 classes by now. We'd have a main class, we'd have a data class, a more data class, and a triangle class. Okay, so down here in main, I'm going to create a couple of triangles. Triangle T1 is equal to new triangle. Let's make a new one, another one. Triangle T2 is equal to new triangle. This is a syntax you'll use over and over and over. You use the new keyword, you use the name of the class, and then you always have to put the parentheses. If you don't put the parentheses, it's going to not compile. And then sometimes you can pass data in. That looks like a function call, doesn't it? Looks like a method. Well, it actually is. And you can write a class that accepts data between those parentheses and uses that to build itself. Now, that's a lecture another day. All right, so T1 dot base equals 10, T1 dot height equals 20. Why did I put those both in the same line? Don't know. And then do the same thing. Make T2 dot base equals something and T2 dot height equals something. I'm going to squish my lines down a little bit by declaring 2 variables on the same line. It's going to say double base comma height. You don't have to do this. I'm just doing it to fit more stuff on the same line. That means I can delete this. All right. Okay, so down here, T2 dot base equals 20. T2 dot height is equal to 40. So it's just twice as big as the other one. Now let's calculate the areas. Double area 1 equals, and then double area 2 equals. Double area 1 equals T1 dot get area. Double area 2 is equal to T2 dot get area. Then we could print those out, right? If we wanted to, why not? System dot out dot print line, printf. Area 1 equals %f, comma, area 2 equals %f backslash n. And then after the comma, I'm going to put a comma, excuse me, after the quote, comma, area 1, comma, area 2.
Scroll back down, please.
I'm trying to stretch it down, it's not letting me.
Oh, okay.
Okay. And phooey. Sorry about that. Guess I should run it before. Make sure I don't have any errors. Alright. Area 1 is 100, area 2 is 400. I guess that's right. 10 times 20 divided by 2 is 100. 20 times 40 is 800 divided by 2 is 400. Okay. Alright. So, I trust it works. So what is happening when it calls get area? Well, it depends on which reference is in front of it. You remember when I was drawing up on the heap, every time it does new, it runs out to the heap and it allocates space? So we had two objects. We had two spaces. And in one space, we wrote into the memory that its base was 10 and its height was 20. And then on the next one, the next object that's out of memory, we said that its base is 20 and its height is 40. And then we called T1.getArea. What it does is it runs up here and it grabs this data from which particular instance we are in. We're in T1, so its base was 10 and its height was 20. Or vice versa, I don't remember. And so it pulls that data out of that particular object. So this is a method acting upon a particular set of data. Remember my definition. It's data and the methods that act upon it. Or the book says data and behaviors. I like mine better. GetArea is a function that uses this data here. Now what I would like for y'all to do in the future, and I'm going to start typing it, is anytime you reference a member of that class, use the this keyword, like this. THIS dot. And then THIS dot. Now that seems like extra typing, but when you look at it and you see that keyword, you see this keyword, you know that the thing that follows it is a member of that class. It's not a global variable, not that there are such things. It's not something that's declared, a local variable that's declared pages up in the code. You know that base is a member of this class. It's an instance member of this class. And if you have height, you know that it's an instance member of this class. Another cool reason to do that is because if you start typing, don't do this, but double D is equal to this dot, you get to see a list of everything. Well, your variables are right up at the top, right?
It says Javadoc not found.
I'll come look at that. That's confusing me. All right, so I'm going to click base, right? So if you type in this dot, it'll list all of the members of that class, including the ones you defined, which are in green. Those are the variables I've defined, and somewhere there should be a get height. Oh, I guess I am defining. Excuse me, get area. I'm not seeing get area, but if
It's right there.
you spotted it? Why didn't I see that?
Between get class.
Finalizer.
Right there, right there. I was hoping it was a different color. It's not, but whatever. Okay, So, I'm really fond of the this keyword. I encourage y'all to use it. Will it work without it? Most of the time it will. But notice I said most of the time. There are occasions when it won't. Why be sorry? I mean, why not be safe? I will explain when it won't work. All right, let me come see what it's saying about Javadoc. So, get area /** get area calculates and returns the area of a triangle. And then so at param, it doesn't have any parameters. But that's boring. Let's leave that off then. And then what are we going to put in the return? It returns a double, which is, so return double returns the area. I'm not going to list the formula. I'm going to delete that comment so I can compile it. Hope that that rebuilds the Javadoc database. We will find out very soon. So then when I come in and I type this dot, and I go to get height, get area, excuse me, you see what it does is it's displaying the information about it now. It's showing us that that's a method called getArea, and it's saying what it does. GetArea calculates and returns the area of the triangle. What does it return? Returns the area. I'm not really liking the way that that looks, but yeah, we could change that a little bit. Returns the area as a double, something like that. So Javadoc is really cool, but it fluffs out the code, right? If you were having to put one of those on every method and one of those on every variable and stuff like that, that is really good programming practice. In a professional environment, you ought to be doing that. I don't make y'all do that. I ought to at least make one assignment where it's mandatory. So if you come up to tools, there should be a Javadoc checker. Analyze Javadoc. Tools, analyze Javadoc. And what it'll do, it tells us what's wrong with it. Create a missing Javadoc for Lecture M. Create a missing Javadoc for main. So, all right, I'll do those, both of those. Fix selected. Now if I go and I look down at main, I'm going to see that it's hoping that I fill out some information about it. Right? I could list what the ARGS does, and I could list what it returns, except it doesn't return anything, and so on. Okay, so Javadoc is cool stuff. I recommend learning. I recommend reading about it, and I will broach the topic again. I think it's an important topic. All right, but we saw how we could create two triangles. We could create as many triangles as we wanted to. We could write a method that accepted a triangle and did something with it. Let's write a method in main that accepts a triangle and does something with it. Maybe it just prints out the information for it, prints out the height and the width. So down inside Lecture M, and I'm going to delete this Javadoc. Down inside Lecture M, I'm going to add, and it needs to be a static method because we're inside a static method, and a static method inside a class can only call other methods in that class if they are also static. So, why not? Public, static, it doesn't need to return any data, so I'm going to declare it as void, and it's going to be called print triangle. And what does it take? It takes a triangle as its argument. So triangle T. T is a lousy name for a variable, but I'm going to run with it. Now I'm just going to put a couple of print line statements. system.console.println. Well, that didn't work. System.capital C console. What am I doing wrong? System.out. Sorry, I slipped into C# mode. System.out.println. This is a triangle. All right. I'm just going to copy and paste that. Height equals space end quote plus t dot height. And then base equals end quote plus t dot base. And let's print the area of it. Area equals space end quote plus t dot get area. Parentheses in, parentheses in, parentheses, semicolon. So in a minute I'm going to scroll down and I'm going to call that function passing in T1, and then I'm going to call that function again passing in T2. Here, after I've created them. So how about print triangle parentheses T1 in parentheses, and then print triangle T2 in parentheses. So we're using the same function to process different pieces of data. Process two triangles. Right? This function can handle multiple sets of data. As many different triangles as we wanted to create, we could pass each one to print triangle, and it would work on each one in turn. All right, and so here it's printing our triangles. Height 20, base 10, area 100. Then it printed out a second triangle. Height 40, base 20, areas 400. And then, it continued to do all the other stuff we wanted to do. And let me stop it and wander around. We have declared a class called triangle. So we're going to write a new class. Write a class, and you can put it in the same file called block. A block has 3 member variables. It's got a height, a width, and a depth. Then add a method called getVolume. It calculates and returns the volume. The formula is just V is equal to height times width times depth. So, this is separate from your main class. So add a new class to your code called block. Okay, and then in your main method, create 3 blocks and print the area of each block.
So do we need to get inputs for them, or do we just...
You can hard code them.
Okay.
Right. because you got the idea once you do that. All right, so height should be declared as a double. Width should be declared as a double. Depth should be declared as a double. And then get volume should be declared as a double. So you're going to say double space get volume, or double space height. Don't be fooled by the idea that I put a colon in this, that means that you need to put a colon in your definition. No, just define this stuff exactly like you defined the triangle class, except it's going to have 3 members rather than 2, and it's going to have a get volume rather than a get area. So it's conceivable this will only take you like 5 minutes if you're looking at your get triangle class and using it as a model. If it takes longer, great. That means that you're digging into it deeper. All right. That makes sense, guys? All right, let's make a Dropbox and do all that kind of fun stuff.